Hi everyone, this is Janine Co, aka Janine The Tutor. Welcome back to another class. Today we will be covering Algebra 2. So we were looking at parabolas from last class, and I just wanted to say that I know this is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are just deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt quickly, and that's why we are running free and daily classes for math and chemistry from grades 11 to first year college and university because we want to help you students stay on top of your studies. So yes, let's get into the class and just wanted to make sure that you can hear me coming through and also if you can see my screen. Okay, great. So I believe this is where we left off from last class. So let's just continue on before we get into the other questions. So today we'll do some factoring as well. So, okay, so here we have a parabola which contains 0, comma 0, we have 1, comma negative 2, and we also have, this is negative 1. I know this is covered, but this is negative 1, comma negative 4, and what is the equation of this parabola in standard form? Okay, so anytime you have a series of points, right? And remember, anytime you have a parabola and if it's in a standard form, this is supposed to be y is equal to ax squared plus bx plus c, right? So all we have to do is set up three equations, namely 0, comma 0, 1, comma negative 2, and also negative 1, comma negative 4. So the first equation, I'll use this coordinate, which is passing our origin. So this is 0, comma 0, therefore we're going to have y being 0, and that's equal to, so our a value is something that we still don't know, and our x is going to be 0, and then we square that, plus b times 0 plus c, right? And why is it b times 0? Because we know that x is going to be 0. Right? So as you can see, we can say that c is simply equal to 0 because this is, so any number multiplied to 0, right, would be 0, and this would also be 0 because b times 0 is still going to be 0, therefore c is equal to 0. So that's that. Okay, great. So we actually found the numerical value of one of the variables that we were looking for, right? Because we needed a, b, and c, so we know that c is going to be 0. So now let's proceed to 1 comma negative 2, right? So if we have 1 comma negative 2, that means our y value is now going to be negative 2. Then our a value is still something that we don't know. Then this would be multiplied to x, which is 1. And then you square that, then this is plus b times 1 because we know that x is 1, therefore b times 1, right? And because we know that c is now 0, therefore we can just omit c, right? So as you can see, we can have negative 2, and this is going to be a, right? And that's just a, right? Because it's only one that's being squared, and then this would simply be plus b, right? Now let's move on to the next coordinate. So we have negative 1 comma negative 4. We know that negative 4 is now our y. So we would have negative 4, right? So I'm still using the exact same equation, which is the standard form. So I'm plugging in y as negative 4, and then you have a times negative 1 because our x is now negative 1. You square that, and then you have plus b times negative 1, and we know that c, right, based from 0, comma 0, c is simply 0. So that's why this is plus 0, right? And we don't need to write 0, right? So if you have this, right, any number that is negative, when you square that with an even exponent, we know that this becomes a positive number. Therefore, this is just a, right? So this is a, and remember you have that equal sign, then you still have the negative 4. So this is a, and this is now going to be minus b, right? So we do have two equations that we need to deal with in order for us to solve what a is and what b is, right? So if you recall, right, back to when we were talking about system of linear equations, we can either substitute or we can eliminate, right, the variables depending on our preference. So again, because we're not being told to use one technique over the other, so we can do both, right? So we need this equation and we also need this equation. So I'm just going to set this up right here. So I have a plus b, which is equal to -2, and I have a minus b, which is equal to -4, right? So a plus b equal to -2, then we have a minus b is equal to -4. So let's say I want to use substitution, right? Just for review, right? So let's say I want to use substitution. So I'm abbreviating my shun as n, okay? So substitution. So if you have to substitute, right, you're going to pick any of your equations, right? You can either pick the first equation or the second equation. So maybe we can pick the first equation and then we're going to substitute a, right? So we're picking the first equation. We're saying a is equal to -b minus 2, right? And why is it -b minus 2? Well, if you move b to the opposite side of the equation, you get -1 as its coefficient, and as a result, you're still going to copy the -2. That's why we have a is equal to -b minus 2, right? And then once we know that a is in this b form, right, in this variable b, we're ready to actually plug this into our equation, right? And obviously we need to use the second equation because otherwise this is just going to cancel out and this is just going to be 0, right? If you plug this back into the equation that you substituted this first equation, right? So if you take the second equation, you see that this is a, right? So because we're seeing that this is a, all you have to do is take -b minus 2. So -b minus 2 would become a, right? Because we said that a is equal to -b minus 2, and this is now minus b, then you have -4, right? So this is replacing this. Okay, so once we have that, all we have to do is solve for b first, right? So maybe if we can get rid of the brackets, we would have -b, right? Minus 2 minus b, then you have equal to -4. You can move the -2 to the opposite side of the equation, turning this into -2 because -4 plus 2 is -2. Then you would have -2b, right? Because you're combining the like terms, -b and -b would give you -2b. So you need to divide both sides with -2, right? As a result, you see that b is actually +1, right? So once you know that b is equal to 1, all you have to do is pick any of your equations. It could be equation 1 or equation 2, and then substitute b being 1, right? So let's say we just take this equation 1 over here. So we said we're looking for a, right? So a is equal to -b. So we have negative, then b is 1, right? And this is minus 2. Therefore, we know that a is equal to -3. Okay, so once we know that a is equal to -3, right? Yeah, we've actually solved for all of our variables, right? We've solved for a, we've solved for b, and also c. So therefore, we can actually say that ax squared plus bx plus c, a is -3, then you have x squared plus b, so b was 1, so that's plus 1 times x, which is just x, right? And c is 0, so you don't have to write 0, so we can just keep it as this. So this is your standard form of the equation. Okay, great. So let's say you're interested in terms of elimination, right, as opposed to substitution. So just going back to these two equations, if you want to eliminate, let's say, the variable that you want. Okay, so I'm picking purple. Let me just resize this so you guys can see. Okay, great. So let's say we want to eliminate as opposed to, substituting. So if we take this equation and this equation, right, we're going to see that this is a plus b is equal to -2, and then the other equation was a minus b is equal to -4. Okay, so right off the bat, I can actually eliminate a without even having to multiply these two equations by -1, right? Because a minus a, right, or 1a minus 1a is simply just gonna be 0, right? And then you have positive b minus minus, right? Just remember you need to distribute this negative sign over here so it becomes 2b, right? So b, Then you have minus minus, so this b becomes positive, so therefore you're going to add the 2, right? So it's 2b now. And then this becomes negative 2 minus minus 4, so it's positive 4, right? So negative 2 plus 4 is negative, what did I just say? Okay, negative 2, and then you have plus 4, right? Yeah, so it's actually positive 2, right? So again, negative 2 minus minus 4 is going to be positive 4, right? So that's why b is in fact 1, right? So b is 1. Okay, great. Maybe we can find the next variable, which is a, right? So remember what I said. All you have to do really is, if you have b, all you have to do is plug in your 1. So I'm taking equation 1. I'm saying, okay, so a is what we're looking for. Then we have plus 1, which is equal to negative 2. Then I have a, which is equal to negative 2. Then this is minus 1, so this is negative 3. So I know that a must be negative 3. Therefore, I can say that y is still going to be negative 3x squared. Okay, therefore I can say that y is equal to negative 3x squared. Then you have plus x, and we know that c is going to be 0. So yeah, that's it for substitution and elimination. So I guess we can move on to factoring now. Okay, so I guess you've probably learned factoring in school, and it's okay, if you forgot some concepts, because I mean, that's the whole point of having this class, right, is to be able to review them. So let's see. Okay, great. So if we want to factor things, right? So I know like some calculators, they do have an option of trying to factor things out. You can definitely use that if you're in grade 11 and grade 12, right? Actually, grade 11, just make it a habit to not use your calculator when you're trying to factor. But anytime, when you're in grade 12, first year, college, and university, you don't really need to know how to factor manually, because you do have your calculators with you, right? But because if you're in grade 11 and into the lower grade levels, right, you need to be able to know how to factor these numbers, because you're not going to be given a calculator during the test. So, okay, so let's start with this question. So we have x squared plus 9x plus 20. Okay. Okay, so anytime when you want to factor something, right, let's start with the basics. So this coefficient is actually 1, right? So we know that a is equal to 1, right? Because there is a difference when you're trying to factor a quadratic equation, right? This is a quadratic equation. So there is a difference between factoring when a is equal to 1 and when a is not equal to 1. Yeah, because it's two different techniques. So if a is equal to 1, as you can see, right, all you have to do is think of two numbers, right, specifically, that when you multiply to 20, when you multiply to each other, so two factors, right, two numbers, when you multiply together, right, so maybe I can think of 4 and 5, right? Okay, so where were we? So we said 4 and 5. Okay, so when you have a is equal to 1, right, when you're factoring a quadratic equation with a is equal to 1, right, that means you're going to look at your constant, which is 20 in this case, and then you're going to think of two numbers, right? When you multiply together, it needs to give you exactly the constant, right? So two factors or two numbers, you multiply them together, you get exactly 20. And this is positive 20, right? And on top of that, so that's one condition, right? You need to think of two factors, you multiply together, right? So first condition is this. And then the second condition would be when you're adding these two factors, right? So say for example 4 and 5 is the one that I chose. They need to add up to 9, right? It has to add up to this coefficient in front. So that's the second condition. Does that make sense? So that's the reason why I'm picking 5 and 4, and specifically positive 5 and 4 is because when I multiply 4 times 5, right, they're both positive. It's going to result to a positive 20, right? And on top of that, when you add 5 and 4, you're going to get exactly 9, which is a positive number as well. So yeah, bear in mind that the signs do matter, because sometimes if it's negative 20, then you need to do something about your factors. Okay, great. So we have 5 and 4, right? So now, how do you set up this equation when you're trying to factor? So one of them needs to be 4, so one of your zeros need to be 4, and one of your zeros need to be 5. So when I say 0, I mean x minus 4, right, is equal to 0, therefore x is equal to 4. Does that make sense? So if you have x minus 5, that means if you have x minus 5 equal to 0, when you move negative 5 to the opposite side of the equation, you get positive 5. Therefore, x is equal to positive 5, right? On the other hand, if you do the exact same thing for x minus 4, you have x minus 4 equal to 0. When you move negative 4 to the opposite side, you get x is equal to 4. Therefore, I know that if you have x minus 4 times x minus 5, you should get x squared plus 9x plus 20. And in fact, if you want to double check, you can actually distribute and apply this apply this method, which is what you call the FOIL method, right? You've probably learned it in class. So FOIL method is basically to multiply this x and x, so you would get x squared, right? And then you move on to x times negative 5, which would give you negative 5x, and then you move on to your inner term, so that means it's negative 4 times x, so that would be negative 4x. And then on the other hand, you would have to multiply negative 4 times negative 5, which would give you positive 20, right? Let's see. Okay, great. So, let's see. Okay, so this is positive 20. I just realized from what I have, right, the question, this is supposed to be a negative 9x. I apologize, this is not x plus 9x. This is supposed to be negative 9x. So just make that correction. Okay, great. So once I have that, okay, yeah, this is supposed to be negative, not positive. So this question, it's x squared minus 9x plus 20, and you need to factor that. Okay, now it works. So when you multiply this negative 4 and this negative 5, this would now be positive 20. So as you can see, when you have negative 5x and minus 4x, this would be positive, this is positive 20, and then you would have negative plus the negative number, right? So you're going to combine them together, so you get negative 9x. Which is plus 20, and then you have x squared minus 9x. Okay, great. So oh, and also, before I even forget, okay, so if you have x minus 4 times x minus 5, because we're on the same topic, so let me just quickly talk about what if you have x plus 5 and x plus 4. So if you have x squared, and this is minus 9x plus 20, as I said, it's a correction. So that's why you're going to get x squared minus 9x plus 20, right? But let's say if you do have, which was originally x squared plus 9x plus 20. Okay, so let's say this is the question. So you have x squared plus 9x plus 20, which was the mistake that I did earlier. Yeah, this is a typo. So apparently it's supposed to be minus 9x. But let's say if the question was truly x squared plus 9x plus 20, right? So if this is a positive number, right, you're still going to use 4 and 5, right? Because both are factors of 20. And yes, they do add up to 9x, right? But the only thing that you need to be worried about is if you have this negative symbol in front as opposed to the positive 4 and 5, right? And the reason why it's important for you to have this negative sign here, which is -4 and -5, is because if you try to multiply the two, you're still going to get a positive number, right? So -5 times -4 is still going to be positive 20. However, if you set this up in this equation, so we know that when x is equal to -5, it would be set up as x plus 5, right? And if we know that x is equal to -4, it would be set up as x plus 4. So when you try to apply the FOIL method here, so you would get x squared, right? And this is plus 4x, and this is plus 5x, and you have, finally, this is positive 20. So as you can see, you're going to see that this is x squared plus 9x plus 20. Okay, so yeah, if it's a negative symbol over here as opposed to a positive symbol, there is a difference between how you're going to set up your factors. So as you can see, these are both positive, right? If these two are positive, that means this has to be a minus sign in front. And then if these two are negative numbers, right, this must be a positive number. Great. Okay, so let's move on to x squared plus 14x minus 72. So if you have this number over here, so you need to think of two factors of 72 that's going to add up to 14, right? So if you have, let's see, 72, let's see, 1 and... Okay, let's try this. If you have these two factors, if you have 4, right, and -18, right? -18, let me just think. If you have -18 times 4, yeah, it's going to be 72, -72. Yeah, it does multiply. So when you multiply 14, positive 14 times -18, you're going to get -72, right? So once you have -72, right, you're going to think, okay, so how do I set up this equation such that I'm going to get 14, right? Well, if you have -18, okay, so we have x squared plus 14x minus 72. Okay, let's say we have x plus 18 and we have x minus 4, right? If you set this up as an equation, right, the reason why this is -18, it's because this is x plus 18. You're going to see that it's going to add up to 14, or when you subtract the 2, you're going to get 14x. So doing the FOIL method, you would have x squared, and this is basically minus 4x, and then you have plus 18x. So can you start seeing this 18x and minus 4x? It would actually give you 14x, right? So that's how I know that it's supposed to be -18 and 4, because first of all, when you multiply -18 and 4, you get -72, and then when you set this up into an equation, you get 14x, right? And then 18 times -4 is equal to -72, which is what we want. So that's why it should be this when you factor. Okay, let's move on to part C. So because you have -x squared plus 13x minus 12, what I like to do is factor out your negative sign first, such that you're going to be left with x squared minus 13x, and this is now positive 12, right? So as you can see, 12 can be split into 12 and 1, right? Which is going to give you 13. So if we have, oh, and also because this is positive 12, right? Let's say if we have -12 and -1, right? If you have -12 and -1, so let's just focus on this inner term first. Let's forget about this negative symbol for now, right? Because we know that this is just going to be copied right here. So if you have, let's say, x plus 12, right, and x plus 1, that means when you applied the FOIL method, you're going to see that this is now x squared, right? And then this is basically, okay, x, right? And then this is 12x, and this is going to be 12, right? So when you combine the two, this is essentially 13x, right? Plus 12, then you have the x squared. Okay, so you have that, right? But the problem here is this 13x, it's not -13, 13, if you know what I mean, right? So in that case, you need to go back to your equation and see whether you need to have a negative sign here or a negative sign here for you to have 13x, negative 13x. Does that make sense? So that means you can't really use plus over here and plus over here because first of all, you need to have negative 13x and not positive 13x. So let's go back to our equation and see what we're going to get if we were to have negative 13x. So if you have okay, let me just erase one of them. Okay, so this is negative x squared, and this is now, let me just go back to the question. Negative x squared, this is positive 13x, and then you have minus 12. This is positive 13x. Okay, so we did factor it, right? I just want to double check to see. Negative x squared, 13x, then you have minus 12. Okay, cool. Okay, so going back to the question, if you have, let's say, positive 12 and positive 1, okay, because initially we had both being negative, right? Negative 12 and negative 1 to give you negative 13. But let's say if you have negative for both, right? In this case, so what I mean by that is x is equal to 12 and x is equal to 1, right? So if you have that negative symbol between x and 12, right, you're going to see that when you expand, yeah, you're going to see that when you expand, if you have x minus 12, then you multiply this to x minus 1. This is now x squared. Then this is minus x. This is minus 12x. And as you can see, this is negative 12 times negative 1. This is now positive 12, right? So this actually adds up to negative 13x, right? Which is what we wanted. Yeah, because this is negative 13x and this is basically positive 12 and we still kept the negative sign, right? So that's why this has to be the answer, because you wanted to have negative 13x and on top of that you wanted to have 12. Okay, great. So we can try this question for the next one. So for part D, so we have to look for two numbers. When you multiply, you get 40, and then basically when you add them up, you get 14. So let's try 10 and 4, right? Because we know that, first of all, if you have 10, you multiply that to 4, you get 40, right? So now because you need 14x, right? That means you need to have x minus, okay, this is supposed to be, okay, let's see. If we had x plus 10, right? And this is basically x plus 4. Okay, yeah, it's gonna work. So in this case, you would have x plus 10 and x plus 4 because when you multiply this, applying FOIL method, you get x squared, then you get plus 4x, and then when you multiply 10 times x, you get plus 10x, and then you get this times this would be plus 40. So yes, it works. So this is your factored form of x squared plus 14x plus 40. So this is in fact 14x and it's positive. Okay, great. So let's move on to this question. So if you have x squared minus 11x plus 30, you know that just by looking at 30, you can have two factors which are specifically 6 and 5, right? Because if you have 6 and 5, there is a way for you to add them up to negative 11x, right? So if you have, let's say, 6 on one side and you have an x here, then you have x, then you have 5, right? Now is for you to think about how you're going to get them to have negative 11x, right? And let's say if you have a negative sign in both equations, right? The reason why I'm suggesting for us to use a negative symbol is because when you add negative 6 and negative 5, so say for example, you apply the FOIL method, you would get x squared, and then you would have to multiply negative 5 times x, which is going to give you negative 5x, and then subsequently, when you multiply negative 6 times x, you would get negative 6x. And then finally, if you have negative 6 times negative 5, you get positive 30 because a negative number times a negative number is a positive number. And as you can see, if you have negative 5 and negative 6, this would add up to negative 11x, right? That's why you need to have x is equal to 6 and x is equal to 5, right? Or in other words, it's x minus 6 because when you move 6 to the opposite side of the equation, right? If you turn this into x is equal to 6, then you know that it's supposed to be x minus 6. And also x minus 5, right? In that sense. Okay, let's try negative x squared plus 14x plus 32. So far, all the questions that we've been doing basically have an a value, which is 1, right? So remember what I said about taking out the negative sign first. So take out the negative sign or factor that out, and you're left with x squared. Then this is supposedly negative 14x, and yeah, if you take out the negative sign, right, this becomes negative, then this also becomes negative. So you do have negative 32. So, okay, let's think about the factors of 32. So for the factors of 32, if you have 16 and 2, right? So 16 and 2. So you need to think about a way that when you multiply the two numbers, you get negative 32, right? So that means if you want to have a negative 32 to begin with, right? Comparing the two factors, 16 and negative 32, right? One of them needs to be negative, right? And the other number needs to be a positive number because the only way for you to multiply two numbers, right, and get a negative number is for one number to be positive and one number to be negative. So maybe we can use when x is equal to negative 2. And the reason for that is because we wanted to get negative 14x, right? So the only way for us to do that is if we have x plus 2 and x minus 16, right, and y, because if you start applying the FOIL method, you would get x squared. And first of all, when you multiply x times negative 16, you get negative 16x. And what else? If you multiply 2 and x, this is now going to be positive 2x, right? And because we wanted to have negative 14, right, the only way for us to get there is if you have negative 17 and positive 2, because when you subtract the 2, you get negative 14x, right? And then on top of that, you still want to have that negative 32. So 2 times negative 16 is negative 32. Therefore, this must be the answer. Okay, so now we're going to get into perfect squares. Okay, yeah. Difference of perfect squares. So, sorry, difference of two squares, right? So this is a good example of difference of two squares, right? And why is it two squares? Difference of, actually, if we have, yeah, difference of two squares, and you're going to see later on what I mean by that. Okay, so if you look at 7, right, and negative 21, you can actually factor out the 7 first, right? And then you keep, so 21, then you have 3, right? So you would have n squared. Okay, so if you have 7, and then you would have n squared, Yeah, 21 divided by 7 is 3. Yeah, so you're going to get 7 times n squared minus 3, right? So because you have difference of two squares, right? I know like for 3, the difference of two squares is not exactly like a whole number like we would think of, for example, 16, right? If you have n squared minus 16, we would think of this being n plus 4 times n minus 4, right? So that's something like that. But for this one, it's actually 3. So you can't really take the square root of 3 unless you keep it in terms of a radical, right? Okay, so let me rephrase that. You can take the square root of 3, but you're going to express it in a radical as opposed to having a whole number, right? It's not like square root of 16 is exactly 4, right? So in that case, when you factor this, right, you're going to have this formula, which is a squared minus b squared, which is equal to a plus b times a minus b. And then from there on, you're going to have, well, a, right, in this case would be n. So that's going to be n. And this is going to be plus square root of 3. And then this is now going to be n, right? So we're just taking the root of n squared, which is n, right? And then you have n minus a square root of 3. So this is your factored form. Yeah, I know it's something unusual because typically if we have squares, right, it would be 9, 3, right? Square root of 9 is 3, and then you have square root of 144 is 12, right? It's exactly a whole number, but in this case we're dealing with a radical. So yes, it's possible, right? But you just have to keep the radical and the number inside. Great, so we have 9x squared plus 9x minus 18. So again, because we have a greatest common factor, which is 9, you can just factor that out. So you would be left with x squared plus x, and this is minus 2. So think about it. If you have two numbers, so you have negative 2 over here, and let's say you have 2 and 1, right? The reason why I'm picking 2 and 1 is because these two numbers, when you multiply, you can get negative 2, but at the same time, you can also get 1, right? By subtracting the two numbers. And as you can see, because this is negative, one of them needs to be a negative number, right? So if you have this one being x is equal to negative 1, right? There is a chance for you to make this positive, right? Because 2 minus 1 is going to be positive 1. So let's say we have 2 and the other one would be 1, right? So actually this should be, yeah, this should be minus 2, right? The reason why this should be minus 2 so that this can become 2x, right? And then the other one would be plus x, so this is just minus 1. Right, okay, so the reason why I suggested that is because if you look at this really clearly, if you multiply this, so this times this would be x squared, and then you have this times this, it becomes negative x, right? And on the other hand, the inner term, it becomes 2x. So 2x minus x would give you positive x, which is what we wanted. And on top of that, you get negative 2, right? So x squared, right? You distribute x times x, and then on the other hand, you get negative x. Then this is positive 2x, and then this is minus 2, right? So you get 2x minus x would give you just x, right? Which is what you wanted in the first place, right? It's positive x that you want, not negative x. And this is supposedly minus 2, right? So you still keep that minus 2 and you still have that 9. So this is your final answer. So it should be 9 times x plus 2 times x minus 1. Okay, let's move on to 4x squared plus 8x plus 12. Okay, so for this question, you've probably seen what we did for h, right? All you have to do is factor out your greatest common factor, and that would be 4. So you would get x squared plus 8 divided by 4, that's 2x, and you have 12 divided by 4, that's plus 3. So you need to think of two factors when you multiply together, you get 3, and on top of that, it needs to sum up to 2. So if you have 3 and 1, that's actually possible, right? So let's see. 3 and 1. Okay, so if we have 3 and 1, that means you would have... Actually, for this question, if you have x squared plus 2x plus 3, even though if you think of the two factors of 3, you have 3 and 1, right? When you multiply the two, basically you're going to get 3, right? But the problem here is if you turn 1 into a negative number, right? So let's say you turn this being negative 3, right? When you multiply this to 1, right? If you multiply a negative number to a positive number, you're going to end up with a negative number, right? So this is actually incorrect. So you can't really do that, right? Because at the end of the day, if you turn this into x is equal to negative 3 and this being 1, in that case, okay, let's set that up. So let's say this is plus 3 and then this is basically minus 1, right? You're going to get a different number because if you have x squared, right, and this is minus x, and this is plus 3x, right? So yes, you're going to get 2x, but the problem here is you're going to get minus 3 as opposed to positive 3. So there's no way you can factor this out unless you want to use imaginary numbers. But the scope of this course, we're not supposed to deal with imaginary numbers, so we're not going to do that. So the final answer would just be 4 times x squared plus 2x plus 3. Yeah, so the reason being is because you're going to have imaginary numbers. And you can't have negative 3 and 1, even though it gives you 2x. Because when you multiply the 2, you're going to get positive 3. Sorry, if you multiply negative 3 times positive 1, you're going to get negative 3 and not positive 3. So this is not possible to factor. Okay, what else? Okay, so if we wanted to look at... Oh, actually, hold on. We can try another one. Actually, if we had 4x squared plus 8x plus 12, right? And, okay, so now... Okay, so I've mentioned that basically when we factor this I, it's basically 4 times x squared plus 2x plus 3. But let's say we apply another trick, which I think we can use here. So if you have a being not, so sorry, if a is not equal to 1 in this case, right? So like right now a is equal to 4. What you can do, you can actually split up 8, right? So let's say you have 4x squared, and maybe we can split this up and have the common factor. Okay, let's try 4. No, actually, if you have 4 and then you have x, so this x plus 1. Yeah, it's not gonna work. Even if you think of a number when you split 8 up into two factors, if you try to group them, so you call this grouping by factoring, so it's not gonna work because if you have, let's say 2, okay, let's say we have 4 and then you have 4. So let 8x be 4x and then the other one being 4x. If you try to factor out the 4, so let's say you're grouping this two numbers and you have these two numbers, so like 4x plus 12. So if you factored out 4, you're going to get this being, let me see, 4. So this being x plus 3, right? Yeah, it's not gonna work. You're going to have 4x plus 4, and then this is going to be x plus 1, then you have x plus 3. No, it's not gonna work for this one. Okay, great. So let's move on to part J to further illustrate what I'm trying to say for this part. Okay, so let's say we have 2x squared, right? Remember what I said about a not equal to 1, then you have 11x. So what you can do, you can actually split up 11x into two factors, right? So, sorry, not factors, but two numbers, right? So when you add them up, you get 11x. So from right now, I can think of 8x and 3x. So if you have 2x squared, and this is basically plus 8x, and this is plus 3x, then you have plus 12. You can group these two and these two. The reason being is if you have 2x, right, you can factor out the greatest common factor between the two is 2x. And then you have x, then this is plus 4, right? And on top of that, you have this plus symbol over here. You can factor out 3, right? That's the greatest common factor for this. You're going to get x plus 4. So as you can see, you can group x plus 4 the same way, right? So you can say that this is going to be 2x plus 3, then you multiply this 2x plus 4. Right. So that's the only way that factoring by grouping is going to work, because if you're able to express the factors in terms of the same x plus 4 in this case, or any term. So yeah, for the earlier questions, we cannot, right? If you have, okay, so the only thing that I can think of is 4. If you have 6, actually, let's try 6. If you have 4x squared and plus 8x plus 12, let's pick 6x and 2x, right? Because they add up to 8x. Let's see, if we try to group 4x squared, so that's going to be, let's say we're grouping this and this. So that would be 2, actually, not. Yeah, it's not going to work if you guys can see this. So if you have 4x squared, let me write this down. So yeah, you have 8x, so that would be 6x plus 2x. And then, as I mentioned, you have plus 12, and this being 4x squared, right? So let's say we group this first, and we group this, and see what we get. So if we take out 2, we get, we're not going to take the x out, because that's not the greatest common factor for this part. So this is going to be x, and this is plus 6. And if you take out 2, right? Yeah, it's not going to work, because this one would eventually be 2x, and this is plus 6. Sorry, 2x, and this is going to be 3 rather, so it's 2x plus 3. So yeah, this is not going to work because it's not the same x plus 6 or 2x plus 3, right? What if we organize this in a way that it's 2x and 6x? Okay, let's say this is 2x and this is 6x. Great. So if we take out 2x, we get 4 divided by 2. This is going to be 2. Yeah, it's still not going to work because 4 divided by 2 is 2. Then you have x here. Then this is going to be plus 1. This is plus. Then you have to take out 6. So yeah, as you can see, it's not the same. So we cannot group this by factoring. Okay, so let's move on to part K. So now we have another A. So yeah, anytime you see when your A is not equal to 1, you need to confirm that when you can actually group this by, group them together and basically factor them out. So if you have negative 4x, right, you can try negative 6x and positive 2x, right, being negative 4x. So you would have 4x squared, then this is minus 6x plus 2x, and this is minus 3, right? So what we can do for now, right? So this is the only time you can apply grouping when your A value is not equal to 1, right? So what I'm going to do is I'm going to think about the greatest common factor between this term and the other term, right? You're supposed to group them together and see if you can get the greatest common factor. So I can take out the 2. No, actually, actually between 2x minus 3, you cannot really take out anything except for 1, right? So we'll just keep this as 2x minus 3. So the coefficient here is 1, but for this, you do have a greatest common factor. So that would be 2x, right? And as you can see, taking out 2x would give you 2x over here, and this is minus 3, right? Because 6x divided by 2x is negative 3, right? So because these two are like terms, we can say that this is equal to 2x plus 1. So the reason why I'm getting 2x is because of this. And you have plus 1 over here, then you multiply this to 2x minus 3. Okay, if you look at 4x squared plus 7x plus 3, right? In that case, your 7x, you can split this into 4 and 3, right? 4x and 3x. And basically, this is plus 3, then you have 4x squared, right? So the reason why I'm grouping this based on 4 and 4 and 3 and 3 is because I just wanted to have just one on each side, right? So if you have this plus sign because of this plus 3x, you're going to have a greatest common factor of 3. Then this would be x plus 1, right? And over here, when you take out 4x, that's the greatest common factor, you're going to see that this is now just x, right? And this is plus 1. Right? And then you have this plus 3 over here. So you can combine 4x plus 3, right? So this is 4x plus 3, and then you multiply this to x plus 1. Great. Okay, so that's it for this question. So now let's move on to part M. So we have 2x squared minus 7x plus 6. So again, all we have to do is think about negative 7x and how we're going to break this into two terms. So let's say we have negative 4x and minus 3, right? Because 7 is basically based on 3 and 4. So we can have negative 4x minus 3x, and you have plus 6. And don't forget, you have the 2x squared here. So the reason why I'm grouping this based on this and this is because if I have the negative sign, the greatest common factor in this side would be negative 3. So I would be left with x minus 2, right? On the other hand, if I have a greatest common factor, which is 2x, I'm going to be left with x. And this is minus 2, right? Close bracket, negative 3. Therefore, you can see that x minus 2 and x minus 2 are similar terms. That's why when you're grouping, it's possible, right? So you would have 2x minus 3, and then you multiply this to x minus 2. So yeah, what I'm just doing right now is basically factoring by grouping. So you need to make sure that when you're trying to group terms together, you need to have a common factor, which is x minus 2 in this case. Okay, a couple things more. We're almost there. So let's say you have x squared minus 6x plus 9, right? So if you wanted to find how to factor this, right? And if you look at your a value, so your a value is actually equal to 1, right? So in that case, you can actually think of two factors of 9, right? And two conditions that you need to apply to that. Remember what I said earlier about a being 1. So the two factors need to be factors of 9. And on top of that, when you add them together, right, it needs to give you negative 6 over here. So let's say you pick 3, right? And 3. Yeah, because 3 times 3 would be 9, right? So yeah, if it's positive 3, okay, I'm just trying to think. If you have, yeah, this would be positive 3 because if you have x minus 3, then you multiply this to x minus 3, right? You're going to see that negative 3 times negative 3 is equal to positive 9, right? Two numbers that are negative, you multiply them together, you get positive 9. And then on top of that, your negative 6 would come from the fact that you're adding 2 negative 3x. So in that case, when you apply the FOIL method, you get x squared Yeah, so you get x squared, and then you basically have negative 3x, and then this would be negative 3x, and then on top of that, this is now going to be negative 3 times negative 3, so this is now going to be positive 9. So as you can see, you have negative 3x minus 3x, so that would give you negative 6x. So instead of saying this x minus 3 times x minus 3 twice, you can just say this is x minus 3 squared, right? I mean, that's what exponents are for, right? So that's why we can say that this is a perfect square trinomial, right? So a perfect square trinomial is basically, we see that this is a trinomial because there's three terms, and perfect square is basically because of this. It's x minus 3, and then you square that. Okay, so let's move on to difference of two squares. So if you have x squared minus 25, right? If you have difference of perfect squares, so difference of perfect squares, basically it's the one that I was talking about earlier. It's the a plus b, it's this one, times a minus b, then you have a squared minus b squared. So in that case, because you have x squared minus 25, right? So this is a squared, right? X squared minus b squared, right? So when you take the square root of 25, you know that that's equal to 5, right? That's why it has to be x plus 5, right? Because it's simply a plus b. And then you multiply this to a minus b, which is x minus 5. Okay, great. Yeah, so okay, so for the next question, how many questions do we have left? Okay, so for the next couple of questions, because it's going to take us a while to complete it, so I just wanted to wrap this class up, and I just wanted to say, thank you for attending my classes. If you're interested, if you found this helpful, and if you're interested in attending more of my classes, please feel free to visit this website. So this is oneclass.com/livestream. So this is where you can see my daily schedule, and also there are a lot of talented educators on this platform who are also teaching math and chemistry. So make sure to check that out. Yeah, so we do have classes daily, and they're from grades 11 to first year college and university. Or honestly, if you're just interested in learning this for the first time, you're always welcome, right? So yeah, thank you so much for tuning in, and I'll see you in my next class. Bye, guys.